In this video, we're going to look at how to use the Gauss-Jordan method for 2x2 matrices. So if we have a 2x2 square matrix, we want to be able to reduce this so that we can get the answers or solutions to a system of equations. So one way you can do that is to find the row echelon form or the reduced row echelon form by finding a matrix which has ones along the main diagonal. So in our case, if we're just focusing on a 2x2 matrix, that would be this case, right? Where we have ones along the main diagonal, which starts in the upper left-hand corner and then ends in the lower right-hand corner, and zeros everywhere else. But this is an example of what it would look like in a 3x3 or 4x4 matrix. And the pattern just continues. That diagonal is 1, or ones are on the diagonal, and then there are zeros everywhere else. Each of those are called an identity matrix. And so the identity matrix is a square matrix, again, with ones along the main diagonal and zeros everywhere else. Oftentimes, you're not given a matrix that looks like that, right? We're given a matrix or a system of equations with a lot of different numbers involved. But you can use your row operations in order to reduce it to look like that. So what you're going to try to do is rewrite your matrix so that the left-hand side of your augmented matrix or your coefficient matrix is an identity matrix, okay? And so the method to do that is called the Gauss-Jordan method. So here's the Gauss-Jordan method. Your first goal is to obtain a 1 in the position A11. So that top left-hand corner, your first goal is to make that be a 1. After that, you're going to use row operations to get zeros under that 1. Okay, then your next goal is to get a 1 in position A22. After you get a 1 in that position, you want to zero out everything above and below that 1. You're going to continue that process with A33, A44, etc. until you get down to the bottom right-hand corner and make that a 1 and zero everything out above that. Again, we're only doing a 2x2 in this video, so it's going to be, just the first, let's say, 4 steps. So solve the system of equations using the Gauss-Jordan method. So we can see that we have 2 equations, so we'll have 2 rows, and then we have 2 variables plus the constant. So our matrix, let me scroll up a little bit, our matrix will look like this. So we will have 2, -3, -9, and then we have 5, 4, 58. And so first of all, let me say that the title says using Gauss-Jordan for a 2x2. And hopefully you can see that this is a 2x3, right? Don't we have 2 rows and 3 columns? We're really referring to the left-hand side or the coefficient matrix. So we're talking about the coefficient matrix when we say 2x2. And it's augmented with the solutions of the equations or the constants, okay? So the 2x2 is just referring to the coefficient matrix. So the coefficient matrix is what we want to make look like an identity matrix. So what we want at the end is something that looks like this. So on the left-hand side, we'll have the identity matrix, and on the right-hand side, we'll have 2 numbers that are there. The great thing about that is that gives us the answers for the x variable and the y variable. And we'll talk about that at the very end. We'll come back to that. So let's go through our process, our Gauss-Jordan method for solving this. The first step is to get your A11 to be a 1. So the first step, A11 needs to be 1. So that is 2 right now. So we want that to be a 1. So what can we multiply or divide by to make that be a 1? Well, if we divided by 2, that would give us 1. Remember, dividing by 2 is the same as multiplying by 1/2. So what we want to do is do 1/2 times row 1, and then we're going to replace row 1 with that. So let's see what we get when we do that. That means we're going to be multiplying times 1/2 times 1/2 times 1/2, right? The entire row. So when we do that, we get 1/2 times 2 is 1. 1/2 times -3 is -3/2. -9 times 1/2 is -9/2. Okay, and now we have 5, 4, 58. So we didn't do anything to row 2 in that step. All right, now second step, the second thing. Get zeros under the first one. So right now the issue is this is not a 0. Let me do that in blue. That 5 is not a 0. We want it to be a 0. So we need to figure out how to make that be a 0. And what you do is you're going to multiply the top row, or the row with a 1, by the opposite of that number. So since that number is a 5, we're going to multiply row 1 by -5. You always do that. And then what you do is you add that to the second row. Once you do that, you will replace row 2 with what you get after you do those things. So -5 times row 1 plus the old row 2 will give you the new row 2. So let's look and see what happens. I'm going to multiply everything in row 1 times -5. Okay, so let's see what we get when I do that. That will be 1 times -5 is -5. Then that will be -3/2 times -5, so that'll be positive 15/2. And then in the third column, I will have -9/2 times -5, so that'll be a positive 45/2. So this is -5 times row 1. Now what I want to do is add that to row 2. So plus row 2, which is 5, 4, 58. Okay, so -5 plus 5. See how those are opposites? That'll add to 0, which is exactly what I wanted. Remember, the whole point of what I'm doing is to make the number under that 1 be a 0, and I've now accomplished that. You will always accomplish that if you multiply the row with a 1 by the opposite of whatever you want to 0 out. Okay, so now we have 15/2 plus 4. So it's 4 over 1. I've got to find a common denominator. So let's see, that'll be a 2. So I can scale up that second fraction by 2 over 2. So that'll be 15/2 plus 8/2. So that will be 23 over 2, I believe. So 23 over 2 is the second element of that row. And then we have to do the same thing with the 45 over 2 plus 58. So scale that one up by 2 as well. So that'll be 45 over 2 plus 116 over 2, which that will be 150/61 over 2. Man, taxing my brain here. All right, 161 over 2. So this is the new row 2. So I didn't do anything to row 1. So I have 1, let me use black here to be consistent. So I have 1 -3/2 negative 9 halves. Okay, and then my new row 2 is 0, 23 halves, and 161 over 2. Okay, so now my first column looks good. I've got a 1 and a 0 in the positions that I want. My third step now is to get a 1 in A22. So this, let's see, 23 over 2 is in the spot where I need a 1. So my third step is to get a 1 in A22. You're always going to do that by dividing by the number that's there. So you would just divide by 23 over 2. Or if it's a fraction, it's really easier to think about it as multiplying by the reciprocal. So you would multiply by the reciprocal. Remember that you can multiply an entire row by something, but not just one element. So in this case, let's move up so we have a little bit more space here. In this case, we want to multiply row 3 by the reciprocal, so 2 over 23 times row 2. So that means we'll do this by 2 over 23. 0 times anything is still 0, so that doesn't mess us up there. Keep trying to write 32. 23 and 2 over 23. Okay, so let's see what we will get. First row, we don't change, so 1, negative 3 halves, negative 9 halves. And then in the second row, 0 times anything is still 0, so multiplying across by a constant does not hurt our 0. The 2's cancel and the 23's cancel out, so that will be 1, which is exactly what we want. That's always going to happen when you multiply by the reciprocal. And then we have 161 over 2 times 2 over 23. The 2's will cancel each other out or divide out. Let's see if 161 is evenly divisible by 23. It would be great if it is. And it is. 161 divided by 23 is 7. Fantastic. Okay, so now I finished the third step. The fourth step is, fourth step is to get a 0 above the 1 I just found. So this negative 3 halves needs to be a 0 for this to look like the identity matrix. So to do that, I have to multiply the bottom by a number and then add it to row 1. You are always going to multiply by the opposite of whatever you want to zero out. So since we're trying to zero out negative 3 halves, we would multiply the bottom by a positive 3 halves. So 3 halves times row 2. You always add that to whatever row you're trying to make be a 0, and you replace that row with that. So we're going to do 3 halves times row 2 plus row 1, and then we're going to replace that with the new row 1. I know this is very confusing at first, but the more examples that you watch and the more examples that you work through, the easier this will get because the process is the same. Okay, so just hang with me. We'll do another example after this, and then you need to go try as many examples as you can so that you get the process down. Okay, so let's see what happens when we multiply row 2 by 3 halves. So 3 halves, 3 halves, 3 halves. So we will get 0, I'm going to put it down here, 0, 3 halves, and 21 halves is what we get when we multiply each of those elements by 3 halves. So this is 3 halves times row 2. That's what we get. Now what we want to do is we want to add row 1. Okay, so row 1 is 1, negative 3 halves, and negative 9 halves. Okay, so let's see what we get when we add those. 0 plus 1 is 1. Negative 3 halves plus 3 halves, do you see that those are opposites? That's what we tried to engineer here with our process, so that'll be 0. And then 21 halves minus 9 halves, well, that will be 12 halves, which is 6. So this is our new row 1. So we have, I'm going to just put it here, row 1 is now 1, 0, 6. And we did not change row 2, so that's 0, 1, 7. Okay, do you see how the left-hand side or the coefficient matrix is the identity matrix? The 1s are along the main diagonal, and there are 0s everywhere else. And then on the right-hand side, we have numbers. This is exactly what we want to end up with. Let's look and see what the associated equations are for this matrix. So remember that X is the first column, Y represents the second column, and then the constants are the ones that are after the line. And then this is equation 1, and this is equation 2. Okay, let's write the equation 1. If I write the equation 1, I have 1x plus 0y is equal to 6. 0y, we don't need to write that. That's just 0. So that's just x equals 6. Well, in that case, do you see that that just tells us the answer? That x is equal to 6, period, right? And that's because we only have a 1 in the x column and a 0 in the y column. So the only thing that's represented in that equation is x. X equals 6. In the second equation, notice that 0 is x, right? And then 1 is under the y column. Again, that means there are no x's in that equation. So the only thing represented in that equation is a y. So that's telling you directly that y is equal to 7. So x is 6, y is 7. Since this is a system of equations, your answer is given in ordered pair form. So the answer to number 1, which is way above by now, is the ordered pair 6, 7. So in other words, that point is where the two lines given in number 1 will intersect. That is the solution to the system of equations. Now, we learned how to solve these system of equations using different methods previously. So we learned about the elimination method, there's the graphing method, there's several ways to solve these systems of equations. Remember though, you'll be asked to solve these with this specific method. So you'll be asked to use the Gauss-Jordan method because we want to see that you know how to use the row operations to get it in reduced row echelon form and solve in that way. Okay, so I don't think I talked about this earlier because I was in the middle of an example, but I do want to share with you the OpenStax link. So this is the URL. You can visit this free college algebra textbook that's available online, and it will walk you through the process. It gives you a lot of examples to work through. So please visit this and get some extra practice here. Okay, so let's look at number 2. I'm going to erase what we did for number 1 for now so that we have a clean slate. Number 2. So we can see that we have 2 equations. So we will have 2 rows in our matrix. And we can see that they are both in standard form. So we have x first, y second, and then the constant last. So we can write our matrix. So -5, 8, 3, and 10, 6, 5. Okay, so our first goal is to make the first entry, A11, be a 1. That's the first goal. So to make that be a 1, remember what we do is we multiply or we divide by a constant. So in order to make that -5 be a 1, we just divide by itself. So we divide by -5. So we are going to do, and you always use multiplication. So we can say we're going to multiply by -1/5, which is the same thing as dividing by -5. So when we do that, we're going to multiply the whole first row by -1/5. Okay, we'll see that -1/5 times -5 is just 1. 8 times -1/5 is -8/5. And then 3 times -1/5 is -3/5. And then we didn't do anything to the second row right now. Okay, next, once you get that first 1, your next step is to make the numbers under that 0. So we want to get this 10 to be a 0. You always do that by multiplying the row with a 1 by the opposite of that. So in this case, it's a -10. Let's see. So we'll do -10 times row 1 plus row 2. So once you multiply the top by the opposite, you're going to add them together so that they zero out. And you're going to replace row 2 with that. Okay, so let's see what we get when we do that. So -10 times row 1. So this is times -10. This is times -10, and this is times -10. So when we do that, we will get -10 plus 80/5 and a positive 30/5. So this is the new row 1. So -10 times row 1 is this. And I shouldn't say new row 1 because we're not replacing row 1. 80/5, I can actually reduce that, right? So let me do that. It'll be -10. 80/5 reduces to 16. And 30/5 reduces to 6. So that's -10 times row 1. Then we want to add row 2. So that's 10, 6, 5. So 0, that's what we want. 16 plus 6 is 22. And then 6 plus 5 is 11. So this is the new row 2. So row 1 stays the same, 1, -8/5, -3/5. And row 2 is now 0, 22, 11. Okay, so we basically have to do the same process now with the second column. This time, though, the second column, we want the 1 to be in the position of A22, and in this case, that's the number 22. So we want our 1 now to be in this position. Whenever you're trying to make something be a 1, you're always going to divide it by itself. So we want to do 1/22 times row 2. Okay, so 0 times 1/22, 22 times 1/22, and 11 times 1/22. Let's see what we get. So we're not messing with row 1 right now. So I'm just going to bring it down. And let's see, when we multiply 0 times anything, it's 0. 22 times 1/22 is just 1. And then we have 11/22, which is actually just 1/2. Okay, now my last thing. Remember, I'm trying to make what's on the left, or the coefficient matrix, be an identity matrix. So what's causing the problems now is I need this -8/5 to be 0. To make a 0, you always multiply the row that has the 1 by the opposite of what you're trying to zero out. So since we're trying to zero out a negative 8/5, we want to multiply row 2, because that has the 1 in it, by a positive 8/5. You always do that. And then you add it to the row you're trying to zero out, and you replace that row. So we're going to multiply the second row by 8/5 and see what we get. So that'll be 0, 8/5, and 8/10. And then we have to add that to row 1. So row 1 is 1, negative 8/5, and negative 3/5. So when we add those, we will get 0 plus 1 is 1. 8/5 and negative 8/5 are opposites, so we get a 0. And then 8/10 minus 3/5. Well, this will really just be negative 6/10. So if I find a common denominator, I will get positive 2/10, which is positive 1/5. Okay, so this is my new row 1. So let's write what I have. My new row 1 is 1, 0, 1/5. And my row 2 is 0, 1, 1/2. Once you get your identity matrix as your coefficient matrix, you have finished or accomplished what you need, because now you have, from the first equation, x equals 1/5, and the second equation gives you y equals 1/2. And so your solution to this system of equations is 1/5, 1/2.